Hello students, today in this video we are beginning with module 1, that is use of free energy in chemical equilibria, electrochemical energy systems and energy storage systems. The topic which I have chosen in this video to be discussed are electrochemical cell, electrode potential, that is cell potential, and electrochemical convention. Now, as you can see here, electrochemical cell. Here is a diagram of electrochemical cell. If you go by the definition of electrochemical cell is, it is a device which converts chemical energy into electrical energy. Now students, the topics such as electrochemical cell, electrode potential, this comes under electrochemistry. Now electrochemistry is the study of chemical processes that causes electrons to move. As you can see here, here is a diagram of galvanic cell. Now what is galvanic cell? Galvanic cell is an electrochemical cell which consists of two half cells which are connected externally with one another. You can see in this diagram there is a zinc rod which is designated as anode, which is dipped in a solution which is kept in a beaker, which is zinc nitrate solution. Here zinc rod is dipped in zinc nitrate solution. This generates a electrode. Now what is an electrode? Basically an electrode is nothing but a metal rod dipped in its own ionic salt solution. Here there is a generation of zinc electrode at right hand side. As you can see in left hand side, there is copper rod dipped in copper nitrate solution. Here there are two separate half cells. These two half cells are connected via voltmeter with one another, which will ultimately form a cell. And to avoid any mixing up of the electrolytes, there is a salt bridge kept. You can see the U-shaped connection between those two beakers is nothing but salt bridge. Basically, salt bridge consists of saturated KCl solution in agar-agar gel. At the bottom of the diagram, you can see the cell reactions to half cell reactions. Zinc is converted into zinc 2 plus ion with the liberation of 2 electrons, and at the cathode, copper 2 plus ions accept those 2 electrons and form Cu. Here two type of reaction take place. Towards zinc anode, oxidation reaction takes place, which is nothing but liberation of electron. Oxidation reaction is nothing but the reaction where liberation of electron takes place. And at cathode reduction reaction takes place. Here those two liberated electrons are accepted by already oxidized species and undergoes reduction. So this is nothing but a electrochemical cell. Next topic students is electrode potential or cell potential. Definition: electrode potential is defined as the potential developed at the interface between the metal and electrolytic solution when it is contact with solution of its own ions. As you can see here, two beakers are there. Metal rods are kept inside the beaker, and inside the beaker there is electrolytic solution. Now let us imagine the metal and the electrolytic solution are of same metal. As you have seen in the previous slide, there was zinc rod dipped in zinc nitrate solution. Okay. Now when a metal rod is dipped in its own ionic salt solution, you can see there will be formation of electrical double layers. Okay. As you can see, the inside the metal, on the metal surface, negative, right hand side, negative ions are being shown, and outside the metal surface there positive ions. So there will be furnishment of negative and positive ions. There will be a pair of negative and positive ions. This is nothing but there will be a potential developing around the metal surface. That potential itself is known as electrode potential. Now what is cell potential? When both the two electrodes are connected with one another, there will be potential which is called as cell potential. Now next topic, electrochemical convention. Now what is electrochemical convention or convention? The meaning of convention is nothing but a way of representing any electrochemical cell. Now here we have seen the diagram of the electrochemical cell. Now all the time we can't draw the diagram, so there must be some notations to represent the electrochemical cell, which are nothing but electrochemical convention. There are number of conventions that are needed in the presentation of any electrochemical cell, which we'll see one by one. So first, cell reaction. Okay. So far we came to know that there will be an anode and there will be a cathode, two electrodes. Anode is negatively charged, cathode is positively charged. Now anode is the electrode at which oxidation reaction takes place, and cathode is the electrode at which reduction reaction takes place. As you can see here, at anode, metal undergoes oxidation and gets converted into metal ion, and loss of electron takes place. Here metal is being converted into Mn plus ions. So n number of electrons can be liberated by the metals. It is a general reaction here. Then at cathode, what reaction takes place? Already metal ions present around the cathode accepts the electrons and undergoes reduction, forming metal. Now next is representation of electrode. Now before representing a cell, we must undergo to represent a electrode. Okay. Now the oxidation reaction takes place at anode. Hence the electrode must be represented as capital M, that is metal, bar Mn plus. So where N plus indicates the oxidation state of that metal. Then the reduction reaction takes place at cathode, hence it must be represented as Mn plus bar M. The vertical line here indicates the contact between metal electrodes and metal ion. Okay students, so next is representation of cell. We have seen separately how to represent anode and how to represent cathode. Now here we need to understand how to place them properly. So first step, anode is always written to LHS, left hand side. Then cathode of the cell must be written at right hand side. And in between anode and cathode there must be two vertical lines placed. So here two vertical lines placed denotes the salt bridge and also denotes the contact between anode and cathode. As you can see here, capital M, metal, bar, Mn plus, metal is in contact with Mn plus, and also it notes that oxidation reaction is taking place, metal to metal ion. Then double bar, salt bridge. Then metal plus ion indicates metal is already in the oxidized form, bar M ultimately reduces. So at anode oxidation, at cathode reduction. So anode must be written first, cathode, then double bar. So here one more trick is there to remember this. So it's ABC trick. So A is anode, B is bridge, then C is cathode. Anode, then bridge, then cathode. Always remember this, students. So example, whatever diagram we have seen in the previous slide, which was zinc rod in zinc nitrate, copper rod in copper nitrate. Zinc was anode, copper was cathode. So for that cell representation is something like this. Zn, zinc solid, bar zinc 2 plus, double bar salt bridge, Cu2 plus, bar Cu solid. So we are discussing here generally. So If in the numericals, if we are mentioning the concentration and all, so concentration we need to write the concentration too. After writing the metal ion, we must write in bracket the concentration. That we'll understand when we'll solve the numerical. So next is calculation of EMF of the cell. So electromotive force of the cell. So electrode potential of the anode and electrode potential of the cathode combinedly will contribute for the electrode potential of the cell. Then what is the formula which relates them? Is nothing but this: E cell is equals to E cathode minus E anode. If E cathode value and E anode value is given, one can easily calculate the E cell value. So this is it, students, in this video. So in the next video we'll understand few more topics from module 1. Thank you.